Hi friends, welcome to my YouTube channel. This is second part of lecture number 2, and in this lecture we will focus on transformer core and windings. First is core of transformer. The core of transformer is of two types. One is core type and another is cell type. So this diagram shows the core and cell type transformer for one phase and three phase transformer. So here this is core type transformer and this is cell type transformer. Now I tell you the basic difference between core type transformer and cell type transformer. In case of core type transformer, winding surrounds the core, while in case of cell type transformer, core surrounds the winding. It is evident from the figure of core and cell type transformer. You can here see that in core type transformer, this winding surrounds the core, while in case of cell type transformer, this core surrounds the winding. Okay. Next important point is core type transformer is made up of two L-shaped laminations, while cell type transformer is made up of E and I-shaped laminations. See how? Suppose these are two L-shaped lamination. If we join these two laminations, then it will make a core type transformer. So this core can be obtained by joining two L-type laminations. In case of cell type transformer, it is made by joining E and I shaped laminations. So this is E shaped lamination and this is I shaped lamination. If we join this, then it will make this cell type transformer. Okay, so next slide. Core type transformer has two limbs while cell type transformer has three limbs. Here you can clearly see that this core type transformer has these two links 1 and 2, and this cell type transformer has three limbs, that is 1, 2 and 3. More insulation is required in case of core type transformer, while less insulation is required in case of cell type transformer. Because in core type transformer, windings are wound on two different limbs, while in case of cell type transformer, windings are wound on a same single limb. That's why more insulation is required in case of core type transformer, while less insulation is required in case of cell type transformer. Flux is equally distributed in the whole core in case of core type transformer. See how it is so. Here we can see that suppose here flux is phi. Okay. So this flux phi will link both the limbs, and that's why flux phi is constant throughout the core. While in case of cell type transformer, so if you see here, suppose here flux is phi by 2, okay, and here in this leg or in this limb, flux is again phi by 2. Now these two flux will add up and the flux in central limb will be equals to phi. So we can say that in case of cell type transformer, central limb carries maximum flux and other two limbs carries flux that is half of central limb. In case of core type transformer, losses are more, while in case of cell type transformer, losses are less. In core type transformer, it is easy to dismantle the 2L-shaped lamination. That's why it has easy maintenance. While in case of cell type transformer, it is tough to dismantle. That's why it has tough maintenance. Next is core type transformer has more losses. That's why its output is low. While in case of cell type transformer, losses are less. That's why it has high output. More copper is required as windings are placed on separate limb in case of core type transformer, while less copper is required as windings are placed on same limb in case of cell type transformer. Core type transformer is also called cylindrical or core winding transformer, while Cell type transformer is also called sandwiched or disc type transformer. In case of core type transformer, natural cooling is not possible, while in case of cell type transformer, natural cooling occurs as it uses distributed winding. Now we will discuss about the lamination of core. Transformer core is laminated to reduce eddy current losses. See, AC current when flows in a winding, then alternating magnetic field is produced in the core. This alternating magnetic field produces circulating current loops that are induced in the core. These circulating current loops are induced by the Faraday law of electromagnetic induction. They cause eddy current loss and core get heat up. To reduce the eddy current loss, core is laminated and made up of a stack of thin steel lamination having non-conductive coating on the surface. So magnitude of eddy current is directly proportional to the area enclosed by the current loop. So area enclosed by the current loop decreases due to lamination. That's why eddy current losses decreases. So this can be understood by this diagram. See here this is the core and here there is no lamination. That's why you can see that this is flux and these are the circulating current. So here we can see that area enclosed by these circulating currents is very large. That's why eddy current is directly proportional to the area enclosed by the current loop. That's why eddy current is large. But if we make this core made up of thin steel lamination, then in that case these current loops get distributed over a very small area. So by doing so we can see that the area enclosed by the current loop decreases. That's why eddy currents decreases. The thickness of laminations varies from 0.35 mm for frequency of 50 Hz to 0.5 mm for frequency of 25 Hz. Now next is winding of transformer. Windings are interlaced to reduce leakage reactance. Concentric windings are used in core type transformer. HV winding is always placed over LV winding. This is for the purpose of cooling. Okay, so HV winding is placed over LV winding for cooling purpose and tap changer is always placed on HV. Okay, why it is so? Because HV handles less currents compared to LV winding. That's why tap changer is placed on HV winding. We know that HV has high voltage and less current and LV winding has low voltage but high currents. That's why it is reasonable to place the tap changer on high voltage winding. Types of winding used for core type transformer. First is cylindrical winding. It uses cylindrical or round conductors used up to 6.6 kV for kVA up to 600 to 750 and current rating between 10 to 600 ampere. Helical windings. They are low voltage high capacity transformer where current is higher. At the same time, winding turns are lesser. Rating of transformer with these windings is 160 to 1000 kVA from 0.23 to 15 kV. Next is cell type transformer. Cell type transformer uses sandwich winding as the two windings near and on the same magnetic axis, so there is good mutual flux linking and lesser leakage flux. So this is all about the second lecture. Now we have finished the second lecture. I hope you enjoyed this video. Thank you.